This is the third part of 3.3. And in this part, we're going to shift gears from talking about even and odd functions to talking about increasing, decreasing, and constant functions. So let's start with a quick graph. And we'll do an example. Let's say that this is t, time. And we'll make 5-minute increments. It'll be 5, 10, 20, 30, 40. And let's say that you're out on a bike ride. And we're going to graph the distance you are from your house and maybe it looks something like this. Where this will be, that can be 3 for 3 miles. This can be 6 for 6 miles. So this is distance from home. And so we want to think about what's going on in this graph. So when you start at 0, 0, which means that you're zero distance at all from your house. So you're starting at home. And about 35 minutes in, 30 minutes in, you're about 6 or 7 miles from home. And maybe this graph is unrealistic, but that's okay because that's saying that in the next 10 minutes, you'll be back home. So you're biking at 30 or 40 miles an hour. Maybe you got picked up. So in the first 8 or so minutes, you're quickly moving away from home. And you would say that your distance from home is increasing. Which makes sense. As time moves on, you're getting further from home, so the distance you are from your house is increasing. In this period of time, you slow down, so it seems like you're going a lot slower because the graph isn't as increasing as fast. Like you've only moved maybe from 3.5 to 4.5 in about 10 minutes, whereas in the first 8 minutes, you went 3 miles. So you've slowed down. So maybe if you're anything like me, you're biking along like a walking path during this point. So you have to go pretty slowly just to avoid people. But then the speed starts to pick back up again. Then it slows down towards the end. And then here you're racing home. We say the function is decreasing because the distance you are from your house is decreasing. And you're just moving really fast, and the numbers are going down. So let's put some actual definitions on this. We say a function f is increasing on an interval a to b if x is less than y implies f of x is less than f of y. So meaning if we plug in a value that's smaller than another value, then that function value should be smaller than the other function value. And we can think about what this meant on our graph, where if we plugged in 5 minutes, we got about 3.5. And then when we plug in 10 minutes, we're up at 4.5. So our function values are greater. And likewise, we have a function f is decreasing on AB if x is less than y implies that f of x is greater than f of y. So meaning as we plug in larger values, our function is getting smaller and smaller. So we can do more of a functional example that asks us when x squared minus 1 is increasing or decreasing. So we know that when we have a parabola, it looks something like this. And we can see, oh my God, my pencil's out again. Well, try and identify for yourself where it's increasing or decreasing. And you should be able to find that it's increasing when x is greater than 0 and decreasing when x is less than 0. But reason through that for yourself. All right. There's a little bit more to talk about maxes and mins. So I'm going to fix my pencil again and pick it up in another video.